First of all, let me know that sound quality, picture quality, everything is fine. Yes, Ram, very good evening. And in this session, we are going to discuss what MSQ, that is the multiple select question, means multiple correct options. It may be one or more than one answer may be correct, right? And it is a new pattern in GATE exam, and that's why we may expect what more questions on MSQ. Okay, so yes, please let me know that sound quality, picture quality, everything is fine. Okay, all good. Thank you, Ram. How are you? Then everyone, please like the session and subscribe our channel and share the link of this session, because this is very important. I'm going to discuss some important numericals from analog. Here we will discuss questions from diode circuits. That is one of the most important topic. Second one is what operational amplifier, and then what BJT, some questions on MOSFET, right, and some questions on oscillator, feedback amplifiers. Okay, so very good. One reminder, sir, at 10 p.m. we have electrical machine. Okay, no issue. Within 1 hour I will cover all these topics, right? So we are going to discuss what 1 mark question as well as 2 mark question on MSQ, right? Last year in electronics, around 22 marks from MSQ, 22 marks, 14 question, right? Around 6 question 1 mark and 8 question 2 marks. So 16 marks from 2 marks question and from 6 marks from 1 marks question, means total 22 marks. So hope so इस साल और नंबर बढ़ने चाहिए. Okay then, so this is my introduction. Myself Sanjay Rathi. I am having around 21 plus years of teaching experience in field of competitive exams like ECE, GATE and PSU. और अकॉर्डिंग टू माई एक्सपीरियंस काउंटडाउन स्टार्ट हो चुका है और अपनी प्रिपरेशन और तेजी से कीजिए विदाउट एनी नेगेटिव थिंकिंग. कोई भी नेगेटिव थॉट्स आपके दिमाग में नहीं आना चाहिए, राइट? क्योंकि इस समय बहुत ही इंपॉर्टेंट है आपका पॉजिटिव रहना. These are my ranks. AIR 16 in ECE 2005, that is engineering services exam conducted by UPSC, and AIR 21 in ECE 2008, and I have mentored more than 1 lakh students for these competitive exams. Okay, then this is all India open mega mock test for GATE 2023 from 24 Jan to what 30th Jan. अब ये लास्ट टाइम है, आप एक बार फुल लेंथ मॉक टेस्ट जरूर दीजिए. ओके, और अपनी प्रिपरेशन चेक कर लीजिए. कोई भी अगर आपका वीक पॉइंट रह गया है तो अभी भी आप चेक कर सकते हैं. एंड हाउ टू यूज स्क्रिबल पैड एंड हाउ टू यूज वर्चुअल कैलकुलेटर एंड हाउ टू सॉल्व पेपर विद इन 3 hours, दैट इज इंपॉर्टेंट. दैट इज वेरी वेरी इंपॉर्टेंट. दैट इज टाइम मैनेजमेंट. तो यू कैन चेक all these through this mock test, that is all India open mega mock. You can register here, that is on our official website, that is BYJU'S exam prep, or on our app. Okay, then Joseph sir, I'm from IIT Roorkee, now going to take one important workshop on 24th Jan at 7:30 p.m. 5 factors to guarantee AIR under 100 in GATE 2024, right? If suppose you are preparing for GATE 2024, then this is the workshop for you. Please note the time, 24th Jan at 7:30 p.m. Okay. Now guys, after GATE exam, definitely some students wants what quick analysis, right? So just after GATE paper on 5th and 11th Feb at 1 p.m. and 6 p.m. Okay guys, that is exam analysis for electrical, electronics, instrumentation and what computer science branch. You have the timetable, you have idea about what about the forenoon session and afternoon session for electrical students, for electronics student and computer science and what instrumentation branch, right? So on 5th Feb and on 11th Feb, please note the time 1 p.m. and what 6 p.m. Complete exam analysis. That session is live session. You can subscribe our channel now so that you will get the notification about this session. पूरा आंसर आप लोगों के सामने रहेंगे जस्ट आफ्टर द एग्जाम. तो उसके लिए आप वरी मत कीजिए, अभी बस फोकस कीजिए कि आपका पेपर कैसे शानदार जाए. ओके, चलिए देखते हैं एमएसक्यू का क्या रोल है. नाउ माय डियर फ्रेंड्स, वेरी वेरी सिंपल क्वेश्चन. एवरीवन ट्राई टू गिव मी द आंसर. दिस इज अ 1 marks क्वेश्चन ऑन एमएसक्यू. यस प्लीज. and just after this session, MSQ on what? Machine, right? So please don't leave this session. Then select the correct statement. To detect when the input is greater than a particular value, use a comparator, right? It is a theoretical question, my dear friends. It may be of 1 mark. Please read the question and which statements is or correct. Normally it is written here, is oblique R. Is oblique R means it may possible that only one statement is correct. It may be the answer like A, or it may be AB, or it may be ABC, or it may be what? ABCD, right? Or what? BC, or what? CD. Number of probabilities, okay? Right? Number of combinations are here, but it is also true that one answer may be correct. Which answers is are correct? To detect when the input is greater than a particular value, use a comparator. Yes, we are using a comparator, right? We are simply using a comparator. Try to understand, everyone. Okay. We are using comparator. Suppose I want to check some value, whether it is greater than or less than some value. Let this is the reference voltage. If the input is greater than 2 volt, output is 1. If the input is less than 2 volt, output is 0. This is called comparator. Okay. It is, always remember, it is not an amplifier, just like what differential amplifier. It will not amplify the difference between the two signals. It will simply give what about the positive terminal voltage with respect to negative terminal voltage, whether it is high or low. That is called comparator. Okay. So this is a comparator. Second one, the trip point of a comparator is the input voltage that causes the output to switch states. What is the trip point? TRIP. Sometimes it is also called threshold point. Sometimes it is also called reference point. Means what? When input cross that value, there will be the change in the output, right? This point is also correct because in case of comparator, for example, let this is the sinusoidal signal. Let this is a sinusoidal signal, and if we have some reference point here, let this is the some reference point, let this is the 2 volt, and this is a sinusoidal signal. Here we are using one comparator. Negative terminal we are connecting the 2 volt and positive terminal we are giving the Vi, and Vi is the sinusoidal signal. Then what will be the output? If the input is less than 2 volt, then output will be 0, and if the input is greater than 2 volt, output will be 1. Very simple. 0. Here it is 0. When it crosses the 2 volt, it will become 1. 0, 1, 0. When it will cross the 0, during increasing journey as well as during decreasing journey, there will be the change, and that point is called trip point. Means this is also correct. This is also correct. A comparator with a trip point of 0 is sometimes called a zero crossing detector. Yes, if suppose this reference voltage is 0, for example, we are connecting it to the ground. When we are crossing the 0, there will be the change in the output. When the Vi is greater than 0, output is 1. When the Vi is less than 0, output is what? 0. Means it is called zero crossing detector. You heard about that type of device. This is called zero crossing detector. Now finally, a relaxation oscillator depends on the charging of a capacitor through a resistor. Is it right or wrong? Relaxation oscillator, normally we are connecting one RC circuit, for example, a square wave generator. When we are having a square wave generator like this, this is C, this is R, and here we are having potential divider circuit for reference voltage. Yes, It depends upon the charging of this capacitor. The time constant depends upon the charging of R and C, and that's why this point is also right. Means in MSQ, it may possible that all answers may be correct. A, B, C, D, all are correct. I think you got the solution, or we have to solve quickly because it is only of 1 mark, theoretical question. 1 mark MSQ, only 1 mark. We can't waste our time, okay, because we have to solve 65 questions within 3 hours. So quickly read the point and give the answer, right? Within 1 minute we have to solve this type of questions. We can't waste our time. To quickly read all these points, give the answer. Partial answer 0 marks. If you are giving all correct A, B, C, D, then you are going to get 1 marks out of 1 marks. 1 out of 1 marks. There is no negative marking. Remember this. Next one. So everyone please give me the answer because there is no negative marking. Which of the statement is are correct for the amplifier? Right? Again, 1 mark question, theoretical. 1 mark only. Read quickly, very simple question. Which of the statement is are? Means one answer may be correct or more than one. The amplifier can be energy converter. It accepts the energy from the DC power supply and convert it to the energy at the signal frequency. Always remember, energy can neither be created nor be destroyed. What about the amplifier? When we are giving the, this is like it is the amplifier. When we are giving the input, like this is the input sinusoidal signal, then it will amplify the signal. And this is the output. The swing of the output increases, means energy of the output increases. Energy can neither be created nor be destroyed. Here we are giving the DC supply. Normally we are giving the DC supply. And here we are giving the input, here we are getting the output. So under suitable condition means, for example, when the BJT is in active region, this DC energy is converted into what? AC energy. And that is the purpose of the amplifier, and the energy of the output is greater than energy of the input, means power of the output is greater than power of the input. The amplifier can be energy converter. Yes, we can say. The process of energy conversion is controlled when there is no input signal. Tell me, if the input signal is 0, what about the output? If the input signal is 0, then what about the output? Output will be also 0. Output will also 0, because in case of amplifier, there should be a bounded output for bounded input. If the input is 0, then output should be equal to 0, but then there is no energy conversion. No energy conversion. The process of energy conversion is controlled when there is no input signal. How is it possible? Not possible. Okay. Then amplifier with positive feedback can be work like an oscillator. Amplifier with positive feedback can be work like an oscillator. Yes, we are giving the positive feedback, and when it satisfies the Bark-Hussein criteria, particular amplifier, when it satisfies the Bark-Hussein criteria, then it is converted into what? Oscillator. We are normally saying that oscillator is nothing but amplifier with positive feedback. Yes, but we have to provide the sufficient positive feedback so that the closed loop gain is nearly equal to what? Infinite. Closed loop gain is nearly equal to what? Infinite. Yes, that is correct. In open loop configuration, the operational amplifier function as a high gain amplifier. What about the operational amplifier? Tell me everyone, it is a low gain amplifier or high gain? But some students were saying, sir, gain is what? RF by R1 or 1 plus RF by R1. But that is a closed loop gain. For any operational amplifier, it is a multi-stage amplifier. It is a multi-stage amplifier, and the open loop gain is very, very high. 10 to the power 6. Very high open loop gain. Okay, that is correct. Okay, now I think that explanation is clear to you. So 1 mark question. Again, I am saying that read question quickly as possible, Okay, then suppose try to understand my points. If there is some doubt, for example, you have some doubt in one option or so on, so please mark the answer, because there is no negative marking. because there is no negative marking. Suppose you are saying that A, C, D are correct, but you are not confirmed about the B, then leave it, but mark A, C and D, right? Because there is no negative marking. Okay. Then, which of the following are advantage of common emitter amplifier? Again, 1 mark question, this type of questions. So only 1 mark. We can't waste our time. Quickly read all the points. So new students, please go through your short notes and go through the properties. Common emitter, common collector, common base, common source, common drain, common gate. And what about the amplifiers? Why we are using this configuration and so on. And quickly try to give me the answer. Which of the following are the advantages of the common emitter amplifier? Right. Only 1 mark. Yes, they will mention, Mohammed. They will mention. This is a MSQ type question. They will definitely mention. Right. Or suppose from this question number this to this is what MSQ they will mention. Or otherwise, always remember, if there is some confusion, they will write like this, is or oblique or. Is are correct. If it is written is are correct, are you getting my point? If suppose, definitely they will mention it is MSQ. But if some ambiguity, then read the question carefully. If it is written is oblique are, means one or more than one answer may be correct. Okay. So which of the following is are, suppose you have just is are advantages of common emitter amplifier. Okay. It provides good current as well as voltage gain. Yes. My dear friend, what about it is not very good or very high, good current gain. Okay. We can say. But sometimes interpretation is very dangerous. Good means what? Moderate. Yes. It is not bad. For common emitter, voltage gain is high. For common emitter, current gain is high or moderate. That's why this point is correct. My dear, we can't say it is a bad current or as well as voltage gain. It provides the maximum power gain of all the 3 configuration. Yes, we can say. Yes, that is the right. Among the common emitter, common collector and common base, the power gain is maximum in case of what? Common emitter configuration. Remember this point. Remember. Now, it has moderate values of input and output impedance. Yes. Yes. There is a change in the language only. Good current gain, voltage gain. Moderate input impedance, moderate output impedance, not too high, not too low. Finally, it is preferable as intermediate stages in multi-stage amplifier. Now try to understand. My dear friend, here we are connecting the input stage. These are called intermediate stage of the multi-stage amplifier, right? Normally, we are connecting voltage source here. When we are connecting the voltage source here, the input impedance of this first stage should be as high as possible. So as high as possible. So for common collector, normally for common collector input resistance is very high. And that's why common collector is preferable for voltage source. Similarly, at the output, normally we want output voltage. Output voltage. The device for which the R0 should be very low. Very low. Then again the common collector is preferable as output stage. So if at the input we are giving the voltage, or at the output if we are taking the voltage, then common collector is preferable. But this for common collector the power gain is moderate. Basically we want to increase the power gain, and power gain for common emitter is highest, and that's why we are using common emitter as intermediate stage. Preferable intermediate stage. Intermediate stages. And if suppose I am connecting a current source here, current source, then remember for current source common base is preferable. For current source common base, the input resistance should be very less than RS. Common base. Again here at the output, if current is required, again the common source. Common base. Common base. If the current is required. across RL. Then common base, because for common base the output resistance is very high, that is in the range of what, mega ohm. That is in the range of mega ohm. Yes, 1 mark question only, because it is a basic question based on the property of common emitter, common collector and what, common base. So this is a 1 mark question only. All are correct. Then if suppose all are correct, then highly confusion, there will be confusion. Now try to understand. Now give me the answer about the oscillator. Now already we have got the idea about amplifier. Now oscillators, my dear students, oscillators. Everyone please read all these points. Which of the following statement is are correct related to the oscillators? Oscillator means, first of all, there should be an output without any input, right? Second, we are saying that amplifier with this positive feedback. Bar-Hussein criteria. To read the point, the frequency of a sinusoidal oscillator is determined by the condition that the loop gain phase shift is 0. What is the Bar-Hussein criteria? The total phase shift when signal travel from basic amplifier to feedback network and return back to the input should be equal to 0 or multiple of what? 2 pi. Multiple of 2 pi. Where n is 0, 1, 2, 3. This is the first criteria, Bar-Hussein criteria. And from this condition, we are finding the frequency of oscillation. Frequency of what? Oscillation. Yes, Rupesh? Now the first point is clear. Yes, the frequency of sinusoidal oscillator is determined by the condition that the loop gain phase shift is what? 0. A frequency for which total phase shift is equal to what? 0. Loop gain phase shift. This is called loop gain. A beta is called loop gain. In every practical oscillator, the loop gain is slightly larger than unity and the amplitude of oscillation is limited by onset of nonlinearity. That is the third Bar-Hussein criteria, practical consideration. What is the practical consideration? The mod of A beta should be slightly greater than 1 to compensate the internal losses of the circuit, or simply we are saying that in that case, if the amplitude increases, that amplitude is controlled by what? Onset of non-linearity present in the system. That is the third statement, practical consideration. Everyone please go through the Bar-Hussein criteria. Practical consideration, third point. This point is also correct. The condition of the unity loop gain minus A beta is called the Bar-Hussein criteria. Yes. What is this? In case of amplifier, actually in case of amplifier, we are having A upon 1 plus A beta. That is the gain with the feedback, right? Try to understand. That is the gain with the feedback. Now, in case of amplifier, if it is the gain A upon 1 plus A beta, that is normally we are saying that less than A. But I want for any oscillator, the closed loop gain or gain with feedback should be equal to infinite. It should be tends to what? Infinite. When it is possible? When A beta is equal to what? Minus 1. When I am putting the minus 1, it will become A upon 1 minus 1 is equal to what? Infinite. So what is the minus A beta is equal to 1? So minus A beta is equal to 1 is called the Bar-Hussein criteria, or mod of A beta should be equal to what? 1. So Bar-Hussein criteria is defined for amplifier. When a particular amplifier satisfies the Bar-Hussein criteria, it is converted into what? Oscillator. And for amplifier, what is the gain? A upon 1 plus A beta. When the gain will become infinity, when A beta is equal to minus 1 or minus A beta is equal to 1. And we are saying that mod of A beta should be equal to 1. And that is the criteria. This is the right statement. Oscillations will be sustained if at the oscillator frequency, everyone give me the answer, what about the D, right or wrong? Oscillations will be sustained if at the oscillator frequency, the magnitude of the product of the transfer gain of the amplifier, this is nothing but A, transfer gain of the amplifier, and the magnitude of the feedback factor of the feedback network are less than, okay, sorry, it is not visible, okay, 1 minute. the feedback factor of the feedback network are less than what? Unity. Mod of A beta is less than 1. Is it criteria? No. Mod of A beta should be slightly greater than or equal to what? 1. Under ideal condition equal to 1. Under practical condition it should be slightly greater than 1. And that's why this point is wrong. This point is wrong. And what is the answer? ABC. What about the marks? Only 1 mark. Only 1 mark question, because very standard question. This is all about what? Bark-Hussein criteria. Are you getting my point, everyone? Yes. To read the points, right? Okay, and don't waste your time. Quickly give the answer. Now, this is a numerical based question, so then it may be of what? 2 marks. It may be of 2 marks. Again, this is the question from standard textbook. That is what Millman Helkias, and they will design the question like this, right? To try to solve this question. Again, if it is of numerical, then 2 marks. Last year in electronics, 8 questions, each of 2 marks, total 16 marks from MSQ. 16 marks. Okay, so electrical students, are you ready to solve MSQ? Instrumentation branch, computer science branch, mechanical, civil, right? In every branch there may be lots of questions from MSQ, right? We are expecting. Then the input voltage Vi varies linearly from 0 to 150 volt. Assume the ideal diodes. Which are correct statements? Which are correct statement? Everyone, that it is buffering or everything is fine, please let me know. अगर आपको सब कुछ बढ़िया लग रहा है, प्लीज लाइक द सेशन एवरीवन. सब कुछ सही चल रहा है, नो प्रॉब्लम. ओके गाइस, try to solve this question. The input voltage Vi varies linearly from 0 to 150 volt. Assume the ideal diodes. Which are correct statement? Breakpoints. Normally it is a question, this is the standard question. They may ask what is the name of this circuit. It is a 2-level clipper. Normally we are saying that 2-level clipper, and we are connecting the 2 diodes. This is the diode, this is the diode, and so on. Then how to solve? Very good evening, Uttar Pradesh Power Corporation. Naveen, Pranay, okay, clear, everything is fine. Okay then. Okay, now in this type of question, if suppose they will ask, then my dear friends, make proper table. Okay, then this is Vi, D1, D2, and what is the output? Because number of question asked here, then we have to solve like this. Okay, and try to give the right answer, because it is a 2 marks question. Then we can spend around 2 to 3 minutes or 4 minutes maximum, and within 4 minutes, yes, it is possible. For example, what is the range of the input? 0 to 150 volt. 0 to 150. So first of all, 0 is less than equal to Vi, less than equal to. Always try to solve this type of question. 0. When I am putting the 0 here, this is the diode D1, this is the diode D2, all are ideal diode. 100 volt value is the highest value, and because it is 0, because of 100 volt this is on, and because of this 25 and 100 volt, the voltage at this point will be positive, because it is positive, it is positive. Here it is 0. On negative side the voltage is positive, on positive side voltage is 0. That's why D1 is off. Initially D1 is off, D2 is on. And when the initially D1 is on, quickly you can draw a diagram where this diode is on. That's why it will act as short circuit. And this is the V0. And this will act as open circuit. This is 100, this is 200, 100, 25 volt. Now write down the KCL at this point, and you can find the value of V0, and it is independent of Vi. When directly I am writing V0 is equal to, sometimes we can directly write 25 into 200 upon 300. This is the 200 plus 100, 300 plus 100 into 100 upon 300. Voltage division rule, or directly you can apply the KCL. V0 minus 25 upon 100, V0 minus 100 by 200. From this you will get 50 volt. you will get 50 volt. Now, if the voltage at this point is 50 volt, the output you can write 50 volt. And my dear friend, when we are going to increase the Vi increases. When it reaches to what 50 volt, then the diode will on. Then the diode D1 will on. So first break point is 50 volt. First break point is 50 volt. Is less than. So my dear friend, the break points are 25 and 100. Wrong. Because the first break point is what 50 volt, and now we are going to increase from 0 to what 150 volt. That's why the first statement is wrong. Now the second statement, when we are increasing the input above 50 volt, D1 is on. Because of 100 volt already D2 is on. Both are on. When both are on, try to understand this. In this question, make the diode short circuit. This is on. This is on. And that is the V0. And this is the Vi. Because of this parallel connection, V0 is exactly equal to Vi. Means V0 follow the Vi. V0 follow the Vi. Okay. Now it is 100 volt. It is what 25 volt. Already now this diode is on. This diode is also on. But what is the voltage at this point? Vi. When this is the 200k. So first of all, always find what is the current through the D2 in this direction from P to N side. When I am finding the ID2, it will become 100 minus Vi. 100 minus Vi upon 200. Okay, this is the value of the current. When this diode will not conduct, or it will it will be off. So when the current is less than or equal to 0, D2 will off. D2 will off. From this you can find the value of Vi. We can say when Vi is greater than or equal to 100, D2 will off. Otherwise it will remain on. So up to 100 volt, D2 will remain off. D2 will remain on, and after that it will be off. Finished. This is already on, now it is off. And what about the output here? Vi. So what about the second statement? Please read the statements also. Output voltage follows the input voltage for the range of input voltage Vi from 50 to 100 volt. That is correct. That is correct. Don't worry about. They will design this type of questions. Okay, numerical based question. This is correct. D2 will remain in conduction for full range of Vi from 0 to 150. Wrong, my dear friend. It will remain in conduction from 0 to 100 volt only. After that, D2 will be off. Minimum value of the output voltage is 50 volt and the maximum value of the output voltage is 100 volt. If this is the question, minimum value. So what is the minimum value of the output? 50 volt. What about the last point? When we are increasing the Vi more than 100 volt, this diode is on, this diode is off. So what about the third diagram? When this diode is off, there will be the no current through the 200 kilo ohm and output is what 100 volt. Here we are increasing the input up to what 100 to 150 volt, but output will not change because that diode is what off. That diode is actually, it is off. It is off. Remove this diode, off circuit. And that's why the maximum value of the output will remain at 100 volt. Okay. So this is the correct one. So which answers are correct? B and what? D only. B and D. Right? They may ask, bhai dekho, this is a new pattern. They may ask any type of question, theoretical or what numerical based. Like in last year, they have given very simple diagram, a high pass filter, and they will ask what is the cutoff frequency and what is the name of this filter. Last year, please watch the paper. Last year, very simple question that is given from the operational amplifier, and it is a standard circuit. This is given. R1, C1, Rn, and this is the V0. And what is the question? What is the name of this circuit? High pass filter, low pass filter. Definitely it is a high pass filter. And what is the cutoff frequency? That was the question, my dear friend. So omega naught 1 by R1 sir. Now you can expect which type of question? Theoretical question. What is the name of the diagram and what is the cutoff frequency? That was the options to B and C. Okay. So from last year, or you can anticipate the question. So theory point plus numerical point. Standard question from standard textbook. So this is the question from Millman Halkias. Okay. Now again the question from Millman Halkias. Right. So how many students solved the question selected numericals from Millman Halkias? Yes. Right. So try to solve this question. The avalanche diodes regulates at 50 volt. Yes, in long session I have given you the idea about which type of questions. Right. So please everyone, first of all, in GATE 2022, go through those questions. Total electrical branch, electronics branch, instrumentation branch. 22 marks on MSQ. Right. So some subjects are common, so that you will get the idea which type of questions they may ask. No doubt we are trying to cover all the topics, all the syllabus, all type of pattern, right? But you can also go through that. Okay, tell me. Now, the avalanche diodes regulate at 50 volt over a range of the diode current from 5 to 40 milliampere. Regulates at 50 volt. What is the meaning of that? Regulates at 50 volt means what? Output voltage is equal to 50 volt. Constant. Over a range of the diode currents from 5 to 40 milliampere. Means minimum current through the diode should be 5 milliampere and maximum current through the diode should be 40 milliampere. The supply voltage is 200 volt. This supply voltage is 200 volt. Okay. And already the breakdown voltage is 50 volt. For proper functioning of the diode, the maximum load current, what should be the value of R? If this is the value and IL is set at 25 milliampere, then supply voltage V may vary between this one without loss of regulation, and that is the power rating of the diode should be more than what? 2 watt. Power rating of the diode. Monica, you are giving the answer A and C for this question. Okay guys, now try to understand. In this question, let this is R, this is Zener diode. Always remember, if RL is connected here, battery is connected here, the fixed voltage is given 200 volt. You have to find the value of R, and this is called IZ, this is called IL, and that is the I. And this is the 50 volt breakdown voltage is given 50 volt. Now, this I is divided into two parts, IZ plus IL. I is equal to IZ plus IL, or we can say IZ is equal to I minus IL. I minus IL. Right? Then we have only two important equations. First of all, IZ minimum is equal to I minimum minus IL maximum. This should be greater than or equal to what? IZK. IZK means minimum current required for the breakdown. That is given as 5 milliampere. So my dear friend, here we are using the VI minimum minus VZ upon R. VI minimum minus VZ upon R minus IL maximum. And it should be greater than or equal to what? 5 milliampere. That is the first case. And that will give you the IZ minimum. IZ minimum. So VI minimum, but this in this question VI minimum is fixed 200. This is fixed. You can find the IL maximum, but first of all you have to find the IR. Second option, second one. This is the first equation. That is the second equation. What is the IZ max? IZ max is given by I max minus IL mean. And it should be greater than, or it should be less than or equal to rating. IZ rating. Here we are using VI max minus VZ upon R minus IL minimum. What is the IL minimum? Is there any value is given? the proper functioning of the diode, avalanche diode regulates that for maximum load current, and nothing, minimum current is not given. So what is the minimum current, my dear students? Minimum current through the RL is what? 0. Minimum current through the RL is what? 0. Suppose I am removing the RL, the complete current will pass through the IZ. The worst condition is minimum current is 0 when RL is infinite. Open circuit. It should be less than or equal to what rating? What is the rating given? 40 milliampere. Rating is given 40 milliampere. Otherwise, they will mention the minimum value of RL here, but they are not mentioned. Yes. Now from this you can find the value of R. First of all, what is the value of R? R should be greater than or equal to. So we can say it is fixed, maximum or minimum fixed. There is no variation. 200 volt. 200 minus 50 divided by R should be less than or equal to 40. So what is the R? R should be greater than or equal to 150 divided by 40. 3.75 kilo. 3.75 kilo ohm. That is the value. So always watch this answer. So what is the R? For proper functioning of the diode, it should be greater than or equal to 3.75 kilo ohm. Means this answer is correct. If but only A and C are correct, then it is incorrect, right? Yes. Yes. Okay, you have given ACD. If ACD, if we mark but only the AAC are correct, then it is incorrect. Yes, incorrect. Otherwise, Monica, otherwise everyone will mark what? ABCD. By out of 4, there may be 2 correct or maybe 1 correct. But if you are giving more than 1, if suppose the A and C is correct and you are giving the ABCD, again 0 marks. Again 0 marks. Now, maximum load current is 3.5 milliampere. So, from this formula, you can find the maximum load current. What is the VI minimum? There is no variation, minus 50. Now, we have the value of the R, 3.75. What is the maximum current? Greater than or equal to 5 milliampere. Now, you can find the value. You are getting the answer, same value, 150 divided by 3.75. Already, that is nothing but 40 minus 5. That is the 35 milliampere. 35 milliampere. But this is wrong. 3.5 milliampere only given. Right or wrong? Right or wrong? Okay, guys. Now you can find the value. You can find the value here. Okay, guys. So this is wrong. It is 3.5 milliampere it is given. So this is wrong. If R is equal to 3.75 and load current is set at 25 milliampere, then the supply voltage V may vary between 162.5 to 293.75 without loss of regulation. Right, my dear friends. Now in that case, in this for C option, you have to verify this. What is the minimum value and what is the maximum value? So always remember VI minimum minus 50 divided by R 3.75 minus 50 divided by R 3.75 minus IL. IL is fixed. What is the IL? Value of the IL? IL is fixed at 25 milliampere. This current is IZ minimum. This should be greater than or equal to what? 5 milliampere. Check this answer and find the value of VI minimum. And for IZ maximum, VI maximum minus VZ, that is 50 divided by 3.7. It is fixed at 3.75 minus current is fixed at 25. It should be less than or equal to 40 milliampere. Now find the value of VI maximum. So what is the range of the VI? You will get the VI minimum, you will get the VI maximum, and it's up to you. Please find the value and you will get this answer. Minimum value and maximum value without loss of regulation. Current is fixed. It's 125 milliampere. Again, we have to use the same formula. Okay. Last one. Power rating of the diode should be more than 2 watt. Power rating of the diode. My dear friend, what is the drop across the diode? 50 volt VZ. What is the maximum current? 40 milliampere. So what is the power maximum? VZ into IZ. 50 into 40. It is in milliampere. 2000 milliwatt. Means what? 2 watt. So So this is the maximum power dissipation across the Zener diode. So what should be the rating? What should be the rating of the diode? It should be greater than or equal to the maximum power dissipation. Rating should be always greater than that value. PZ rating should be always greater than or equal to what? 2 watt. That is the correct. So A, C and what? D is the correct answer for this question. Okay. So Monica, now you can check. Yes, everyone. Please check the second option. Already a third option. Already I have given the formula. You can use this formula and please take a screenshot. Okay. Okay, guys. So this type of theoretical question on what circuit. Now next one, everyone try to give me the answer for this question. Some questions on operational amplifier. Tell me what is the name of this circuit. Quickly give me the answer. But standard, it may be of 1 mark. Sometimes they will give what 2 marks question. For the circuit of figure with an ideal operational amplifier, which statements are correct? It is a standard circuit. Yeah, we are having around 20 standard circuit in operational amplifier. Please try to get all theoretical part about all these diagram, standard diagram. They will ask this type of questions. It is a all pass filter. It is a minimum phase system. Range of the phase shift at the output V0 with reference to the input is from -pi to 0. It is a low pass filter. Tell me which answer is correct. Yes, please. My dear friend, it is a standard circuit for all pass filter, and that's why the first statement is right. What about the second statement? Give me the answer in comments box. Whether it is a minimum phase or non-minimum phase. All pass filter. Range of the phase shift at the output V0 with reference to the input is. My dear friends, always I have given the hint in my all classes. If this is just like a low pass filter, no doubt overall system is high pass filter, but it is a low pass RC circuit. Then it is a lagging circuit. Lagging. What is the phase shift of this provided by this? From -pi to what? 0. If I am changing the position of R and C, I am connecting R here, C here, then the phase shift will become 0 to pi. So this statement is correct, right? But when it is a high pass filter, so what about this? It is not a low pass filter. This is wrong. And what about the B option? Right or wrong? Everyone tell me. What about the B option? Here, yahan par control, we have to use the concept of what? Control system. Minimum phase, non-minimum phase. And in control system, we are using the all pass filter, right? It's a compensator to adjust what? Lead and lag, right? Leading circuit or as a lagging circuit. Please tell me. So it is a lagging, a low pass filter is a lagging circuit, and that's why we are having the phase shift -pi to 0. If suppose I am changing the position of R and C here, R here, try to remember, it will give the phase shift from 0 to pi. Now it is a non-minimum phase. Non-minimum phase. This is wrong. Non-minimum phase system. Okay. So control system, you will get the idea about that. All pass filter is example of non-minimum phase system. So it is A is correct, C is correct. A is correct, C is correct. Then all questions on standard circuits. Quickly, 1 mark question only. MSQ 1 mark. Again, it is a standard diagram. Revise it. What is the name of this circuit? In the operational amplifier circuit given in the figure, load current, it is given in the figure. Where is the VS is connected? What is the name of this circuit, everyone? Now, my dear friend, this is R1, this is R2, it is connected. Normally, we are having the RF, R1, RP, R2. There is a 2 feedback, negative feedback as well as positive feedback. Here I am connecting the RL. This is non-inverting terminal, inverting terminal. It is a standard circuit for voltage to current converter. Voltage to current converter. So it is a voltage to current converter. First statement, please go through the statement. If the one statement is voltage to current converter, in exam hall, it will give you the hint. Yes, it is a voltage to current converter. Okay. Now, once you will get the idea, it is a voltage to current converter. My dear friend, when we are giving the input to inverting terminal or non-inverting terminal, first of all we have to check the ratio RF by R1 and RP by R2. If the RF by R1 is equal to what? RP by R2. RF by R1, R1 by R1, RP by R2, R2 by R2. So it is satisfied. If it is satisfied, if the input is connected to non-inverting terminal, that is the non-inverting terminal, then the output is Vs by R2. That is current is Vs by R2. If the input is connected to inverting terminal, in this question input is connected to inverting terminal, this is the Vs, this is grounded, then the current will be, this IL will be Vs upon minus Vs upon R2. What is given here? Minus Vs upon R1. Subra Reddy, are you getting my point? That's why this is wrong. Why it is wrong? Because in this question, my dear friend, if it is connected to inverting terminal, then output will be minus Vs by this resistor. Minus Vs by R2. It is given minus Vs by R1. That's why it is wrong. Minus Vs by R2. If the Vs is connected to terminal 2, this is the terminal 2, that is the non-inverting terminal, and terminal 1 is grounded, then IL is Vs by R2. Yes, that is correct. If the input is connected here, then answer will be Vs by R2. This is correct. It is a voltage to current converter. Again, this is right. Then, positive feedback is dominant as compared to negative feedback. Remember one thing. When we are giving the voltage, it is converted into what? Current. Right? There should be a bounded output for bounded input. If suppose the input signal Vs is 0, then output current should be equal to 0. Means there should be what? Negative feedback should be dominant. Otherwise, this circuit will not work. So negative feedback is dominant. Otherwise, operational amplifier always goes into what? Saturation. So positive feedback is dominant as compared to negative feedback. This is wrong, and answer is what? B and C. Answer is what? B and C. So in my session, already I have proved that in this particular diagram, the negative feedback is dominant. Negative feedback is dominant. Okay, guys? You can watch my previous lecture on voltage to current converter. This is again a standard diagram. They may ask question on all the standard diagram like inverting operational amplifier, non-inverting operational amplifier, logarithmic amplifier, anti-logarithmic amplifier, voltage to current converter, current to voltage converter, okay, differential amplifier, and so on. Next, try to give me the answer. B and C is the correct one. Any doubt? If you find any difficulty, then please ask. Now we are going to solve 2 or more questions. Then quickly try to give me the answer. Yes, please. Then, and after that you can join what? Machine, right? Please join that session. Machine by, right? So MSQ on, very important subject, that is machine. In the operational amplifier circuit given in the figure, the feedback in the circuit is positive. Again, this is a standard diagram. This is the operational amplifier. This is the transistor. 5 kilo ohm resistor is connected. 10 volt is given here. 1.4 kilo ohm is connected here. 5 volt is connected here. In the operational amplifier circuit, the feedback in the circuit is positive, right? Okay. Again, it is what? Biasing of the BJT. The feedback in the circuit is positive. No doubt this point is connected here, my dear friends. This point is connected to the positive terminal, but the negative feedback is dominant in this diagram. It is used for stabilization of this transistor, right? Then this is the 5 volt. According to virtual short concept, Vp is equal to Vn, that is equal to 5 volt. This is 5 volt. What will be the current here? 10 minus 5 divided by 5, 1 milliampere. 10 minus 5 divided by 5, 1 milliampere will be the current through the 5 kilo ohm resistor. Current to the operational amplifier, it is 0, and that's why the same current will pass here. And the voltage from this point to this point, that is the VBE. So sometimes we are taking the VBE is equal to what? 0. It is varied between what? 0.6 to what? 0.8. What is the average value? We are taking 0.7. So if I am taking that 0.7 here for silicon transistor, so what value of the V? 0.7 plus drop across this. So what is the value of the current? 1 milliampere. So we can say V is equal to 0.7 plus 1 into 1.4. around 2.1, nearly equal to 2.1 volt. So voltage V at the output of the op-amp is 2 volt. Yes, we can say nearly equal to. Why? Because VB varies between 0.6 to 0.8. If it is not given in the question, otherwise remember, VB varies between 0.6 to what? 0.8 volt. If suppose I am taking the 0.6 volt, then it is satisfied. 0.6 plus 1.4, that is the 2 volt. We can check. Power dissipation across the 5 kilo ohm resistor is 5 milliwatt. 5 kilo ohm resistor. What is the power dissipation across the RC? I square R. I square R. What is the current here? 1 milliampere. 10 raised to power minus 3 the whole square into 5 into 10 raised to power 3. You are going to get the 5 into 10 raised to power minus 3 watt. And this is nothing but 5 milliwatt. First of all, convert it into what? Ampere, and register in what? Ohm. I square R. And then this is the in watt, and convert it into milliwatt. And that's why this answer is also correct. The voltage V at the output of the op-amp is 0 volt. That is wrong. The feedback in the circuit is not positive. It is what? Negative feedback. Remember, right? So this is the very, very important diagram. That is the biasing of BJT with the help of what? Operational amplifier, where operational amplifier will provide you the negative feedback, and highly stable circuit. Highly stable circuit because of the operational amplifier. Any doubt, then you can ask anyone. Anyone you find any difficulty with respect to this question or previous question, you can ask here. Right? This type of questions. 2 marks question. This is a 2 mark MSQ. Which answers are correct? You have to mark the answer. Okay. Then sometimes they may ask question on what? Current mirror circuit. Current mirror circuit by using MOSFET. Again, it is a standard circuit. We are expecting MSQ on what is standard circuit. So current mirror circuit. Quickly give me the answer. Which statement is are correct? In the current mirror circuit, output current depends upon the load. My dear friend, under standard, always remember, in a current mirror circuit, output current is forced to equal the input current. This is equal to what? I reference. And here we are connecting the load. It may be capacitor, it may be inductor, it may be any type of load. And always remember, I naught is independent of the load. It is directly equal to what? I reference. And that's why it is a very, very important theoretical point. It is called voltage to current converter. And current should be independent of the load in case of current mirror circuit. This current is equal to what? I reference. And it is independent of the load. And that's why this statement wrong. Second, when two perfectly matched silicon transistors are connected as shown in the figure, the value of beta is very large. Yes, that is the property. Both the transistors should be identical. Beta should be as large as possible. That is given in the question. Very thousand, very large. The value of the current I is 4.3 milliampere. This is I is nothing but I naught. Is 4.3 milliampere. Okay. Now in current mirror circuit, when I am writing the KVL from this point to this point, KVL from this point to this point, then we can say 0 is equal to I reference. This is the I reference into 1 kilo ohm plus this is the 0.7 volt minus 5. So what is the I reference is equal to 5 minus 0.7 upon 1, that is nothing but 4.3 milliampere. And I naught is exactly equal to I reference when beta is very, very large, or otherwise I naught is equal to I reference divided by 1 plus 2 by beta. Remember this is standard answer, right? I am not going to derive it. You have the idea about that. Go through your formula notes, you will get the idea. Am I correct? If the beta is very, very large, then 2 by beta is less than 1 and it is nearly equal to what I reference. Otherwise, this is the exact answer. Yes, 4.3 milliampere. If the beta is very, very large, the value of I naught is 4.3 milliampere. In part B, if the beta is 20, then I is what? 4.3 milliampere. No, no, it is always less than 4.3 milliampere. 4.3 milliampere, always less than. You have to use this formula if the beta is small. So 4.3 divided by 1 plus 2 by 20. 1 plus 2 divided by 20, that is nothing but 1.1. 4.3 divided by 1.1 means it is less than what? 4.3 milliampere. And that's why if the beta is not large, then this answer is wrong. No need to calculate. No need to calculate. It is always less than 4.3 milliampere. Quickly give the answer. In the part B, if area of the emitter base junction of Q1, which one is the Q1? Definitely they will mention. Normally if nothing is mentioned, this is the Q1, that is the Q2. Normally it is the Q1, it is the Q2. In the part B, if the area of the emitter base junction of the Q1 is double of that of the transistor Q2, then I is equal to 8.6 milliampere. Everyone tell me, what about this answer? Right or wrong? What about this answer? If the area of the transistor, emitter base junction of the transistor Q1, this is the Q1, right? I am giving you the answer. This is the Q1 and that is the Q2, is double. Then I is equal to 8.6 milliampere. My dear friend, try to understand. Always remember, we are comparing the area of this transistor with that transistor. Okay? So when I am comparing this transistor with that transistor, what is the actual answer? The formula is emitter base junction area of Q2 is X time E by J of Q1. Then the current will become X times of I reference. Here emitter base junction area of Q1 is given double. Which means it will become what? Half of that. What is given here? In the part B, if the area of the emitter base junction of the transistor Q1 is double. So what is the area of the Q2? Half of that. What about the I0? Half of the I reference. What is the half? 4.3 divided by 2. But here it is double given. Here the double is given. Right. In part B, if the area of the emitter base junction of the transistor Q1 is double of that of the transistor, then I is equal to 8. I is nothing but I0. This is I. My dear, it is half. This is wrong. Are you getting my point, everyone? Yes, that is clear. Read question carefully. Ek English, each and every word is important. Remember, each and every word is important. If you are going to give the partial answer, 0 marks. You are giving this is right, this is right, this is right according to you. Right? No doubt you have judged ABC and simply you are making mistake. 0 marks. Okay. Read question carefully. Then, next one. I think this is clear to you. Now, my dear friends, last class I have given you the idea about the precision rectifier. How many students attended that session on precision rectifier? Precision rectifier. Right? Half wave rectifier, full wave rectifier. Tell me. Consider the following circuit. The function of a diode D1 is avoid positive saturation of the operational amplifier when the input is negative. So in a previous class, each and everything about this diagram. To my dear students, new students, please try to attend that session on rectifier and precision rectifier so that you will get the idea about this diagram. Okay, everyone. Now, try to understand this is a standard circuit. What is the function of D1? For example, this is called VA. And here we are giving VI. Because it is an operational amplifier, when it is connected to what negative terminal, we are connecting the input to the negative terminal. When the VI, right, when we are giving first statement, when we are giving the VI less than 0, for example, when I am giving the VI less than 0, VA will be positive because of 180 degree phase shift, VA will be positive. When the VA is positive, D1 is on. Because of positive value at this point, D1 is on, D2 is off. Once the D2 is off, D1 will provide negative feedback. D1 will provide negative feedback, and that's why it will avoid positive saturation. Yes, otherwise it will goes into what? Saturation. goes into what? Saturation. Yes, definitely D1 will avoid positive saturation when input is negative. This is correct statement. Avoid the positive saturation of the op-amp when the input is negative. So when we are giving the negative voltage, this diode is on. When this diode is on, it will avoid the positive saturation, and that's why we are getting this output. Okay. The function of the diode D2 is to avoid negative saturation of op-amp when the input is positive. Just opposite statement. The function of the diode D2 is to avoid the negative saturation of the op-amp when the input is positive. Everything is negative. Yes, this is changed. Positive is converted into negative, and input is negative, it is converted into positive. That's no need to check. This statement is also right. Otherwise, you have to check. When the VI is positive, VA is negative. Because of this negative, this diode is on, that diode is off. It will provide you the negative feedback, and operational amplifier will never goes into saturation. Right? So that is the case. That is the negative saturation. Figure shows the transfer curve. Everyone tell me, this is right or wrong? This is right or wrong? Saurabh. Saurabh is saying that this is the right. Yes. So what is the standard diagram? When the D1 is on, my dear friend, VI is less than 0. VA positive. This is VA is positive. D1 is on. D2 is off. Always remember, when D1 is on, there is a feedback. V0 will become minus R by R into VI. That is, R by R is cancelled, minus VI. Output is minus VI. Okay. Or when it is greater than 0, it is negative. Because of this negative, D1 is off, D2 is on. Always remember, D1 is responsible for the rectification. Once the D1 is on, output is 0. Means we are getting the output when the input is negative. When the input is positive, what is the output? 0. This is the output. What about the transfer curve? When the input is positive, output is 0. When the input is negative, output is positive. And that is the transfer curve. Here the slope is what? Negative. तो कई लोग बोलेंगे सर बहुत ही फास्ट बता दी. अरे already I have taken the complete session on precision rectifier. Please attend that session. 2 days back. 2 days back I have taken this. Okay. So this is right. PIV of the D1 is equal to the supply voltage. No. Operational amplifier will never goes into saturation. Because of this diode, it will avoid the saturation, and that's why the PIV of the D1 is equal to the supply voltage. No. PIV of the D1 as well as D2 is nearly equal to what? Only 0.7 volt. Only 0.7 volt, and that's why this is wrong. Why we are connecting the D2? To reduce the PIV of the D1. What is the purpose of the D2? It will avoid the saturation. That's why the PIV decreases, and that's why the D statement is wrong. Okay, 2 marks question, everyone. Very, very important one. All about the precision rectifier. अब यार कब भरोसा करोगे आप लोग पेपर में आने के बाद कि अभी हो रहा है थोड़ा बहुत भरोसा आपको? यस, आर यू गेटिंग माय पॉइंट एवरीवन? लास्ट 2 क्वेश्चन. Please give me the answer. Very simple one. Tell me fast. 1 mark question. Which statements are correct? Darlington pair is common emitter, common base. Yes or no? Darlington pair. Darlington. Common emitter followed by common base. Darlington pair is also known as super beta transistor. Cascode amplifier is a direct coupled amplifier. For differential amplifier, the figure of merit is CMRR. Which are correct? Only 1 mark question. MSQ. MSQ 1 mark. Tell me which answer is correct. Darlington pair is common. No, common collector followed by common collector. Wrong. Common collector followed by common collector. Yes, Rupesh Reddy, your answer is correct. Darlington pair is also known as super beta transistor. Yes. Because the current gain is very, very, very high. What is the current gain of the common collector followed by common collector? 1 plus beta square. if the beta is 100 or 99, it will become 10,000. The current gain will become 10,000. This is a very high current gain. Effective current gain is very high. That's why it is called super beta transistor. So that is the right answer. Cascode amplifier is a direct coupled amplifier. Yes, this is also correct. Actually, the cascode amplifier is common emitter followed by common base, and it is the direct coupled. We are not connecting the capacitor, right? We are not connecting the capacitor, and that's why it can amplify the DC signal as well as AC signal. Again, theoretical question, right? For the differential amplifier, for any differential amplifier, the figure of merit is what? Common mode rejection ratio. Common mode rejection ratio, BCD. BCD is the answer for this particular question. Okay, B, C, D. So this is again 1 mark question, theoretical. I think no doubt in this question, everyone. No doubt. Everything is fine. Yes, B, C and D. Then next one. So here this type of questions, theoretical question, right? And I am going to ask one more important question. Sometimes this is the, first of all, give me the answer for this one. Which statements are correct about the tuned amplifier? Tuned, theoretical question. Tuned amplifier. Or wideband amplifier. My dear friend, tuned amplifier means here we are connecting the RC by LC circuit. This is the tuned amplifier. Remember this point. It is used as internal stage for super heterodyne receiver. It is a LC tank. In place of RC circuit, we are using the LC tank circuit. Which statement? It is a narrow band amplifier. It is not a wide band amplifier. It is a narrow band amplifier. The quality factor is very high, and that's why the bandwidth is very small. Are used in the radio transmitter and receivers? Yes, it is used as a first internal stages of what? Super heterodyne receiver for proper selectivity. Performance is determined by the Q of the circuit. Definitely Q is very, very large. That's why the bandwidth is very, very small. F0 by Q. F0 is the resonance frequency and Q is the quality factor, and that's why the bandwidth is very low, and that's it is called narrow band filter, narrow band amplifier. Single tune amplifier is a class C amplifier. Now we have a class A amplifier, class B amplifier, class AB amplifier. So B and AB used as what? Power amplifier. And here we are, this is the tune amplifier is nothing but class C amplifier. Means Q point is below cutoff. Q point is below cutoff. So remember this point. In a class A amplifier, Q point is in the middle of the active region. In a class B, exactly at cutoff. Class AB in between A and B, and class C below cutoff. Class C below cutoff. And tuned amplifier is a class C amplifier. That is the again right statement. Theoretical question, 1 mark question. We may expect 1 marks only, no problem, but 1 marks, each and every marks is important. Right. Last but not the least, last one. Ready guys? And I want to give one homework. So this is the assignment for you. Everyone give me the answer in the comments box. This is the homework. Please take a screenshot. This is a numerical based question. You can find the answer for this question, but quickly you have to solve. It is a 2 mark question on MOSFET, 2 mark MSQ. Multiple correct answer, numerical based question, and that's why easy question you can solve, but it will take time. It will take time, guys. Try to solve this one. And then everyone tell me what is the answer for this question. In a voltage feedback as shown below, which of the following statements are true if the gain K is increased? Everyone please watch. I am going to share my Telegram channel link. Please give me the answer. What is the answer for this one? For your doubts, for the PDF, please join my this Telegram channel, right? So that you will get the notification as well as the PDF of this session also. Okay. And that is my Telegram channel, Electronics by Sanjay Rathi. Okay, guys. So I think, it is not possible to cover each and every questions from each and every topics and so on. Are you getting idea which type of MSQ they may ask? Go through your short notes, right? And what about the properties of the circuit, right? Number of standard circuit, common emitter, common collector, common base, common source, common gate, common drain. What is the difference? What about the different techniques of stabilization? For example, cell bias circuit, fixed bias circuit. This type of questions they may ask. Okay. Definitely. Just after this class, I will share this. Okay. Definitely, I will share this time. Okay. Now, in a voltage feedback as shown below, which of the following statements are true if the gain K is increased? Gain K is nothing but beta. This is called feedback network. Here we are sampling the V0. And here we are mixing the V0 because Vin is connected here. This is the VF. We are sampling the V0. We are mixing the V0. So here it is a series connection. Here it is a shunt connection. At the output shunt connection, at the input series connection, we are sampling the voltage. We are mixing the voltage. What is given here? Which of the following statements are true if the K is increased? So my dear friend, in this type of feedback, because the input series connection, input resistance increases. So what is the formula? Formula is without feedback 1 plus beta AV. So here beta is nothing but K. So if the K increases, what about the input resistance? Increases. The input impedance decreases. Wrong. If the K increases, beta increases, input resistance increases because at the input we have the series connection. Right? The output impedance increases. My dear friend, at the output we are having the shunt connection. So what is the output impedance? R0 upon 1 plus beta AV. If I am increasing the beta, what about the overall output resistance? It decreases. Beta means K. Increases, R0 decreases. And that's why this is wrong. Now, we are just opposite statement. Definitely this is wrong, then this is correct. The input impedance increases, output impedance decreases. C or D. So again, give me marks. How many marks? Everyone tell me. 1 marks or 2 marks? Here, very simple. Again, it is a standard diagram. It is a standard diagram. Right? No doubt, we are expecting what 1 marks only because it is a standard diagram. A, B wrong, just opposite statements. That's why CD is correct to 1 mark question. But if suppose in exam we are getting 2 marks question, so what about the level of the paper? Now we can say the level is what? Easy. Level is what? Easy. And that is the way. In this way we can judge. So we are expecting, sir, it is only 1 mark question, but in exam hall it is of 2 marks. Extra bonus. You are getting the bonus. So please try to avoid what silly mistake in that case. Try to avoid silly mistake. तो ज्यादा ओवर एक्साइटेड मत हो जाना, वाह ये तो मुझे आता है तो मैं कुछ भी सॉल्व कर लूंगा और जाके पता चला हड़बड़ी में आपने गलत मार्क करके आ गए. आपको ये बस अपना पेशेंस रखना है. मैंने एक सेशन लिया है 5 डाउट्स 1 minute सेशन. आफ्टर दैट यू कैन वॉच दैट 1 minute शॉर्ट 5 डाउट्स दैट मे अफेक्ट योर व्हाट गेट 2023. तो प्लीज अवॉइड दैट और कभी भी हड़बड़ी मत करो. राइट पूरा भी 10 minutes मेडिटेशन कीजिए और 10 minutes मेडिटेशन के साथ अपने आप को पूरी एनर्जी को कंसंट्रेट कीजिए. और जब आप एनर्जी को कंसंट्रेट करेंगे तो ज्यादा अच्छे से आप पेपर बना पाओगे. अब 10 दिन बचा हुआ है, 10 मिनट रोज ध्यान लगाने की कोशिश करो. 10 minute मेडिटेशन डेली. राइट. तो एग्जाम हॉल में आप अपने डेटा रिकॉल भी कर पाओगे, आपको कॉन्सेप्ट भी याद आएगा और वी कैन अवॉइड व्हाट सिली मिस्टेक्स. दैट इज मोर इंपॉर्टेंट. एंड ट्राई टू गिव व्हाट minimum 3 to 4 full length mock test. Right? Okay then. So this is all about this session, my dear friends. Hope so you enjoy the session. Please join everyone. The next session, that is on machine. So this is a gate and ECE test series. Get unlimited access to full length mock tests, subject wise test. Link is given in the description box. Link is given in the description box. Why? 60 plus tests covering the gate and ECE, detailed mock analysis, virtual scientific calculator is available, 4000 practice questions, all India open mock test, and curated by what? Gate experts. Okay then, so join my Telegram channel. Just after the session, I will upload the PDF of this session. Quickly, I am going to upload the PDF without any password. Then you are on BYJU'S exam prep. Subscribe, like and share the link of this session. And please scan this so that you will get the link of our Telegram channel and link of our official website. Thank you and good night.